I welcome you all to this online tutorial. We are still on biochemistry of homeostasis. And in this case, we are concentrating on buffer system of the body. So these are the objectives we are going to achieve at the end of the class. 1. We should be able to explain buffer system. 2. You should be able to write Henderson-Hassel equation and the uses of the equation. 3. Composition of a buffer. What are the composition? What made up of a buffer system? 4. Factors affecting pH of a buffer. 5. Factors affecting buffer capacity. 6. How do buffer act, or the actions of a buffer? Then finally is what? How do buffer act? So listen carefully as we proceed. So looking at it, now we'll be looking at what? We say that buffers are solutions which can resist change in pH when acid or alkaline is added. So, and this buffer, they are responsible for the maintenance of pH of plasmas, okay, intracellular fluid, ECF, extracellular fluid, and the tissue of the body. You know we have different kind of buffer. We have bicarbonate buffer, which is at the extracellular fluid. We have phosphate buffer, which is what? At the intracellular fluid. And we have hemoglobin buffer, protein buffer, and so many of them, okay? We also have acetate buffer, and so many of them, okay? We'll be looking at them one after the other in this case, okay? And their main duty is what? To resist changes in pH when alkaline or acid is added to the solution. That is a major work of a buffer. Now, the pH of a buffer system is related to concentration of its weak acid. See now, the pH of a buffer system is related to concentration of its weak acid as well as what? Salt and the conjugate base of weak acid and pK of weak acid. What means that this buffer system is made up of buffer solution, and this buffer solution have a pH because it's made up of what? Acid and a conjugate, weak acid and a conjugate base, made up of salt and weak acid, and so many of them. So they have their own pH. This pH, it depends on the concentration of the weak acid and the what? And the conjugate base. And this can be expressed in using Henderson-Hassel equations, in which the equation says that pH is equal to pK. Okay? pK is also the same as pKa. Either you see pKa or pK, they are the same. That pH is equal to what? pK plus logs salt or conjugate base all over acid or weak acid. Okay? So if you see salt all over acid, they are correct. If you see conjugate base all over weak acid, it is correct. Okay? But in this equation, I want you to take notice of what? pK, pH, salt, acid. Take notice of it because you keep making reference to these equations. Okay? Okay, what is the uses of this equation? 1. To know the pH of a buffer solution. If pK of weak acid and the ratio of the acid and its base are known, I show you now the equation is to know the pH of that buffer solution. If you already know the value of pK, and you know the value of your acid and your conjugate base, you can find your pH. 2. So 2 is to determine the concentration of weak acid and its base if the pH of a buffer solution or pK of a weak acid are known. So this is what we are talking about. I want you to look at the equation and see what we are talking about. If the first is to know the value of pH, if the pK and the acid and the weak acid, if the value is known, you can find your pH. Okay? And the second one says we can also find our pK if the value of this acid is, if the value of this pH is known. Okay? And the value of your what? Salt and what? Acid is known. You can find your pK. That's what we are referring to then. Okay? Then we say that what? When the concentration of weak acid and its conjugate base are known, means pH is equal to pK. So what are we talking here? Means your acid is equal to base. Means in this equation is like pH is your acid and your pK is your what? Your base or your alkaline. Because you say when the concentration of the weak acid and its conjugate base are equal. So this is your weak acid and this is your conjugate base. When they are equal, okay, then the above equation become like this. Okay, when they are equal. Okay. So now we move to composition of a buffer. Buffer of two types. Okay, there are two types. And these two types, let's see their composition. Composition 1. Mixture of weak acid with their salt and with a strong base. Okay, it is one composition of buffer. So this one of the composition of the buffer, it have weak acid. That weak acid will also have its salt, like acetic acid. What is this? A salt of acetic acid, acetate. Okay, with a conjugate base. That's what we mean. And then 2, now we said, which is the B now is what? Mixture of the weak base. Okay, mixture of the weak base with what? With the salt of the base and the strong acid. Okay, that is the two composition of what? Of a buffer. Now, to explain further, see examples, relevant example. This is what? Carbonic acid. This is the salt of what? A carbonic acid. So a buffer that have these two composition of what? Weak acid and what? And the salt of this acid, we call them what? Bicarbonate buffer. If it is carbonic acid, okay, carbonic acid or sodium bicarbonate, we call it what? Bicarbonate buffer. Okay, so the buffer type depends on the composition that is present in that buffer. Okay, so carbonic acid and sodium bicarbonate. This is your carbonic acid, this is your sodium bicarbonate, and we call it what? Bicarbonate buffer. So number 2 example. This is your what? Your acetic acid, and this is your sodium acetate. This is your sodium acetate. Okay, and we call it what? Acetate buffer. Acetate buffer. Having a composition of acetic acid and sodium acetate. That's what we are talking about. And then look at your phosphate buffer. You see now this is disodium hydrogen phosphate or sodium dihydrogen phosphate. You see now. So, and we call it what? Phosphate buffer. So we proceed to factor affecting pH of a buffer. And the factor that is affecting the pH of a buffer are 2. 1, the value of pK. Okay? The value of pK. That the lower the value of pK is the lower the pH of the solution. Because pH is equal to pK. pH is equal to pK when the value of your acid to a conjugate base is equal. Your pH become pK. So that's what we are talking about. That the value of pK affecting the factor of the pH of a buffer. That the lower the value of pK, the lower the value of what? pH. And B, the ratio of the salt to acid concentration. Okay, the ratio of the salt to acid concentration also affect will also affect what? The pH of a buffer. Then 2, now we move factors affecting buffer capacity. You know, buffers is a solution that resists change in pH when acid or a base is added. Is that not so? But for the buffer to do its work well, there are factors that affect it. What is number 1? We said, on the other hand, buffer capacity is determined by the actual concentration. So, actual concentration of salt and acid that is present. The actual concentration of the salt, you know that equation again, if you can remember, the concentration of the salt to that acid will affect buffering capacity. Okay? And then buffering capacity is the number of grams or strong acid or alkaline that is necessary for a change in pH. Okay? It's also another factor that affects it. And 2, buffering capacity of a buffer is defined as the ability of the buffer to resist change in pH when an acid or base is added. Okay? Ability for the buffering capacity to resist change in pH when an acid or a base. So if you can do that job well, it's also determined at what? The buffering capacities. Okay? Now, how do buffers act? Buffer solution consists of a mixture of a weak acid or base. Okay? I have shown you that earlier, and it is salt. For the case of acetate buffer, what do you see? You see acetic acid and you have sodium acetate. The sodium acetate is the salt, the acetic acid is a weak acid. And if the weak acid now dissociate, it will give you what? Your conjugate base. So all this in there were part of what? Buffer solution that we are talking about. Now we proceed. So to take an example, when hydrochloric acid is added to acetate buffer, the salt will react with the acid, forming weak acid, acetic acid, and it is salt. You see now that when hydrochloric acid, which is already a strong acid, is added now to acetate buffer, this acetate buffer is already a buffer, and then it's started to add hydrochloric acid to this buffering system. What will happen? See now, it says the salt will react and it will form now weak acid and what? Acetic acid, and it is salt. So acid and salt is still in the system. Okay? So in that case, what do you think? Means there is no neutralization. Means the buffering capacity has not worked. Okay? But similarly, when a base is added, if it is a base that you add, instead of adding hydrochloric acid, if you add a base to this as acetate buffer, it will form what? Salt and water. And so pH and what? Minimize. Okay? Means there is no change. But in this case, there is change. Means there is no buffering capacity. But here the buffering capacity, because the pH changes, is what? Minimize. So let me give you solid example here. How do buffer add continue? So now look at it. This is what? Our weak acid. Look at sodium hydroxide added to it. So this sodium hydroxide will be able to neutralize the effect of this acid in the body, in the system, and then it will give you salt and what? Water. Now in this case, the pH change is what? Minimized. Buffering capacity is working. But in this case, look at now hydrochloric acid added to acetate. At the end, you still have what? Acetic acid, which is acid and what? And then sodium chloride, salt, acid and salt. So in this case, there's changing in pH, and so the buffering capacity is not working. So now the buffer capacity is determined by the absolute concentration of this salt and acid, you see now. But the pH of the buffer is dependent on the relative proportion of the salt and acid. So why this buffering capacity depends on the concentration of this salt and acid, it depends on the concentration. But pH depends on the proportion of the salt and acid. So this one depends on the ratio. Proportion means ratio. This one pH depends on the ratio of the salt to acid. Okay? That's what we mean. So when the ratio between salt and acid, like now, this is our salt, is 10, and then Okay, we proceed. When the ratio between salt and acid is 10:1, means your salt is 10, your acid is 1, which will be 10:1. The pH will be 1 unit higher than pK. And pK when pH is equals to pK, means your acid is equals to base. Is that also means in this case your pH will be 1 unit higher than what? Than pK. Okay, but when the ratio between salt and acid is 1:10, means your salt is 1 and then your acid is 10, the pH will be what? 1 unit lower than what? pKa. Okay, that's what we are talking about. So this ratio, we are looking at it in relation to what? pH. Okay. So now action of a buffer. Taking acetate buffer as an example. Action of a buffer is given below. Now listen carefully now. The two components of acetate buffer are acetic acid, which you already know this. Acetic acid and what? Sodium acetate. You already know this. But now let's see what happened now. To know the action of a buffer, how did the buffer work? How did it work? That's what we mean by action of a buffer. So in justifying this, when acid like hydrochloric acid is added, the base component of buffer system is shown below. Now look at it. This is our sodium acetate, which are the component of acetate buffer. When this hydrochloric acid is added, it will give you what? Acid and what? Sodium chloride, which is acid and salt. So in this case, the buffering capacity is not working at all. Okay, because buffer is supposed to resist change in pH. Okay, but in this case, you know it is not favorable. But since acetic acid is weak acid compared to hydrochloric acid, the pH changes is little. Means the only why the pH changes here is little is because this one was just a weak acid. But if this one is a strong acid, this one is a strong acid like that, you say that more harm should have caused to the body. But in this case, the pH changes little. But on addition of this hydrochloric acid to acetate buffer, okay. But when alkaline like sodium hydroxide is added, acetic acid of the buffer react and neutralize changes in pH. So the word that is very important here is that what? When you add sodium hydroxide to acetate buffer, it neutralizes the effect. It neutralizes every changes in pH. It neutralizes every changes in pH. Okay? On addition of alkaline. Now look at it now. This is what? Acetic acid. When sodium hydroxide is added, salt and water. Now the pH changes is minimal. It will neutralize every effect. Thus, we can now say in this case of last equation, that buffer resists change in pH when acid and alkaline is added because of what we just experienced here. But in this case, buffer is not doing its work at all. Okay. So, and that is it. Thank you for listening, and then we'll watch out for the next video.